Could have brought my clicker. I could have actually been professional. So unfortunately, this is my job.
What's your job?
I am basically I'm a sales engineer for Red Hat. So
You like to do presentations?
Conference presentations, I do probably 30 a year.
You should be teaching us.
The only thing I can teach you is it's fun. I really, after being terrified initially, I just discovered I really love doing it. And my favorite thing is the fact I don't memorize any presentations. I make them up on the spot.
Well, it's probably the best way to do it because then you don't have to worry about did you
Yeah.
have a script. You know?
Exactly. I freaked out the first time and forgot what I was going to say, so I had to go,
Yeah.
extemporaneously, and it was so much less stressful.
About 15 minutes or not 14 minutes now.
Now, go for it.
I don't know if that'll work on the Mac, but I have a clicker.
Oh. I
The
think it will.
USB widget?
That's a Surface, so I think
Oh,
it
is
will.
it a Surface?
It is
Okay.
a Surface, so that's
Yeah, it looks like a
fantastic.
Mac, yeah.
You say, next slide, please, and then hit it yourself.
Let's see here. Is it on?
No, it's just it's the one thing on the side. Thumb wheel.
Thumb wheel?
Yeah. Oh, here.
Oh,
Yeah,
it
there it
works.
goes.
Fantastic. Go for it.
Wow.
Thank you very much.
You're welcome.
Probably. So what's
Now
your
we can see
connection?
how many times I go backwards accidentally.
Yeah, I use it
Almost
for
looks
mine
like
on
a
Thursday.
mini USB.
Luckily, I didn't go back.
Yeah, this one's nice.
Yeah.
Oh, it's a keyspan money. I love keyspan.
Oh, yeah, it's old. I mean, that's probably as old as the Apple II.
They still make them though.
I know they
Keyspan
do.
looks like
Yeah.
Yeah, we have mini and regular HDMI.
Yeah, they make the nice
blown
ones, slim ones.
I'll leave this with you.
That thing's gotta be 10 years old.
I like the bigger ones, honestly. I've got two.
This
I've got one that's a
thing
really strong,
here-
powerful laser pointer.
No, that's running the plug-in
And then I've got one that's
which
Logitech with display showing my timing and all that. Then I've got a
The
big
laser
one.
pointers I needed.
Okay,
Yes.
so
See, that's nice. And the
yeah,
fact
if it
that
goes to
a lot of them don't
HDMI,
show
you
on the screen.
can
Right, yeah.
just plug it directly into the projector.
Which one did you get? 'Cause I like that one. I've been in
These are
tonight.
on Amazon. Honest to God, these things get like 3 of them for $10.
Really? Because I paid a lot of money for mine. Oh, that's a lot, right?
They do.
Yeah, see, that's great. If you, would you be willing to send me a link?
I will send you the link for it. Yes.
It is. But there's a big difference in the grain cell. I tried a number of them, and a lot of them will fade in the background, especially if you have like a blue or green background.
Or an
But
LCD
that one does
screen.
not.
So
Yeah, that'll
nice.
shine on an LCD screen too.
Yeah, that's
you're ready, we
fantastic.
just need to change you around.
Way better than mine. And again, mine was $100, which is sad. 'Cause that's way
Leave the
better.
cable up
Yeah,
here.
honest to God, I'll just go on Amazon and your email, I'm assuming is up on, will be up on.
Actually, it's not, but I can tell you what it is.
Oh, all right. Yeah, we'll get it done.
Quick question,
Yes.
any Hackfests, but you,
Yes. Yes.
anybody in here doing Hackfest? Anybody else?
He's doing Hackfest, but he has to
I know,
present.
Yes.
we have actually.
Yeah,
You know
they've
about him?
already-
Okay.
Thank you, Martin.
Give me 1 second here.
All right, I'm ready to
And your email?
Is JJ AC
AC,
OC
OC,
KS
KS,
at Mac.com.
at mac.com.
So it's my first initial and my last name at Mac.com. I should have put it on there.
Mac.com represent.
Yeah, I've been using it since, actually, it's JJ Cox at iTools.com.
Yeah, I have.
Since beta. That's really cool. And you're Alex as well, so you got the right name.
I was at bike shop just to start back then. Do that, how did you get a Mac.com? And it turned out she worked at an Apple store. We're starting a bike shop. I'm like, oh, okay. Way back before I caught it.
Yeah.
We're grandfathered in.
And I'm sure you remember all the ridiculous instability and the outages. And
Oh yeah, you know, I've got
Oh.
I like the path of least resistance, and so it was hard to move off, but there were some rough years.
There were.
Where they'd send us free stuff, like a free copy of EverQuest.
Yep.
Like, please don't leave.
Yeah, iTools was really unstable. I still stuck with it, and I have it to this day. I will say that email address just forwards to Gmail right now, but I've kept it forever.
What's this thing?
It's
Oh, this thing.
Podcasting
Podcasting one. Okay, it's off. So to turn it on, we have to take this and pull it back like that, and then it has to go through a little startup sequence.
Okay. Zoom.
And when it's done with this little hourglass thing.
Although, at the time iTunes came out, there wasn't a lot.
No.
Certainly free.
Okay, so you push the record button once and it flashes, and you push and then you push it again and it's recording. And now
I
it's
see the little
recording.
record thing.
And then later on he just merges this with the video to get a good sound on the video. And we just have to make sure it's pointing to the person who's speaking, at least in their approximate direction.
Okay. Just probably there. Yeah.
Yours be like couch. Quick question.
Yes.
When you're talking, are you going to be standing here or are you going to be
I'm
wandering?
going to be moving.
Like how
you
far
want me to?
How far will you be moving?
Probably like here to here.
Oh, yeah?
Okay, so in that
just point it
case,
that way.
we'll just
But
have
if you
to.
want me to stand still, I'll try and do it.
No, no, no. We just want to point the microphone roughly in your direction.
Okay. I
Well,
talk
see,
pretty
we
loud too, so I don't think.
And the we'll see the wireless mics. At least the sound should be better on both sides of the room now.
Okay.
The mics are still flaky,
I
and they're going to go on and off. And
What's your choice?
Well, we
I
have
don't
two
have to
mics,
use
though.
it if you don't want me to.
no, feel free to use the
Okay.
mic.
Because I'm loud
helps-
enough to anyway.
It probably helps some to have the sound in the back of the room better.
Oh, okay.
But just be aware of the fact that the things you might help to
Right.
tap it a little bit, but it's
Here,
just
can you
kinda-
hear me well in the back?
You could use the other mic though.
Okay. How about like this?
Because one of them's not
Better?
flaky, right?
Because I can use the mic or not.
know.
I'm just trying to decide. Since they're unreliable.
Oh, he's got one there. Okay.
Yeah.
So start with that one. If it gets flaky, we'll switch to the other one.
Yeah.
Let's put it as close as I can to my mouth too. Maybe that will help it.
The other thing is ask Charles because he's further away. Right back in the corner. There's also an ACU to do it. Yeah, that's another reason why I asked him.
Yeah, it's working.
Yeah, it sounds good to me.
For now.
For now.
All right. So let me pick
I
up my
know how to
stuff.
start the live stream, and I know how to take the computer game off of it.
You know how to
It
change.
took me a
How's
while to
my
figure that
head?
out yesterday.
You know how to change the words so that they read the thing properly.
I know how to change the text.
Okay.
Yep.
All right. So it's just this coming up.
Here,
right
I
now.
went to, I
Coming up
normally
part.
would have
Okay.
outside.
All right. Let me get my mess out of here.
I did exactly the
And I
same thing.
didn't today, and I'm like already feeling it.
Until a couple days
I
ago.
tan pretty nice, but like the top of my head, that it used to have hair for years and years and never burns. Like it hasn't become accustomed to.
I had a nice red circle around the top of my head because I did suntan lotion when I was at the beach last week, and I forgot my hair. It's a perfect red circle around here.
Oh.
I'm half priest, so I have the top. Because I guess I'm a tan now. My wife Danish, English, Polish, and German. Yeah.
And none of them see much sun.
Yeah, no, my wife's pale white, and my son's the same way, and they both burn. And my daughter, she's got the like nice Mediterranean skin, so we're like super tan, and they're like super red.
One of my closest friends is Filipino, and he has the best skin. He just does not ever burn. Because I'm a former racer, so I spent all day at the racetrack, and I just come out bright red and peeling all over the place, no matter how much suntan lotion. No problems for him. Obviously, still skin cancer risk, but
Oh yeah, for
he
sure.
doesn't hurt
I mean,
as much,
for
but
sure. I've actually recently I made a point to.
Yeah.
I put it on the kids because you don't think about it because you don't. It doesn't hurt. You're like, oh, I'm really like.
yeah. Yeah, same thing. My 3-year-old daughter, I'm constantly covering her with suntan lotion.
Consider the sheep trough.
They got really nice.
For a lot of purposes,
really
as far
nice
as.
sprays.
The only good thing about her, as far as that goes, is she absolutely loves to bathe. So if you give her some liquid of some kind, she will cover herself with it every time. Yep.
So far, it's been exciting.
Well, hopefully I'll maintain this level of excitement.
Okay. Presentations are a lot different than experiments. Exciting experiments are not necessarily good.
Exciting presentations can also be a very bad thing because amazingly bad things can happen during them.
For the speaker, yeah.
I'm sure you've seen the number when the speaker accidentally does a stage plunge because they're walking so much. Like I tend to walk all over the place, so if you get to the edge of the stage, just
I've seen that.
Conveniently, we have our stage.
it's much safer that way.
Yes. All about safety here is concerned.
Yes, that's what I have on the. Yeah, that's what mine said.
So I'll try to give you a copy of that one.
Okay.
That far from the
Yeah, I have enough material probably for 2 or 3 hours, so it's probably a good idea.
Okay.
And time goes a lot faster when you're standing up there.
In all the presentation I've done, I've never run out of material. There's always more. And especially on this subject, there's so many possibilities, so many things have changed, and there's tons and tons and tons of different opinions, and a lot of them are fairly valid.
Yeah. And there's so much new stuff coming out every day.
Yep. And before I forget, tangential to this presentation, there's actually a really nice makerspace just down the road from there. I forgot my samples, so they happily agreed to print very cheaply for me some samples to be able to show you some of the things I've made.
Oh, cool.
So they're just down the road, less than 5 minutes from here. So anyone who lives nearby, called Hammer Space. Look them up. They're nice people. They have a really amazing makerspace with a ton of different equipment.
Okay, welcome back from lunch. Alex Jaycox is going to talk about 3D printing for fun and profit. Okay, just for fun.
So as Martin just said, I'm here to talk about 3D printing, and particularly I'm going to talk about 3D printing as it applies to vintage computers. Really doesn't matter. It's pretty much the same everywhere, but some techniques are more or less applicable. The thing I'm hoping that you all will get out of this is the fact that it's really not very hard to get started doing this. You all have all the specialized knowledge necessary, which is knowledge of the system or knowledge of whatever it is you're trying to build, and that's really the most important thing. So, brief history of 3D printing. It may be older than you think it is. I did not realize that 3D printing really got started in 1981. We have Hideo Kodama. He basically invented the idea, or his institute. It's not really clear how much is him specifically, but his name is on the original paper, describing a rapid prototyping system that uses photopolymer. That's what will eventually become SLA. It is not clear whether he actually built it or not, but he described it in detail. 3D Systems founder Charles Hall invented stereolithography. which is and then created the STL file format, which is the standard file format that most 3D printing is done with. It describes 3D objects using triangles. The founder of Stratasys, I don't know, has anyone heard of Stratasys or 3D Systems? Okay, at least somebody. So Stratasys and 3D Systems are leading professional 3D printing manufacturers. Stratasys, as far as I know, is the largest in the world. Anyway, Scott Crump invented FDM 3D printing, or fused deposition modeling, which basically is like extruding plastic. So, if you think about squeezing a tube of toothpaste, that's FDM. And then in 1992, 3D Systems created the first useful stereolithography machine. So it took between 81 and 92 for the idea to become practical. And stereolithography works in that you have a photopolymer, which is a liquid resin, and then you have either a laser or a DLP, and it basically heats that resin to solidify it. And it does that layer by layer. So slice and build up. So, as I mentioned for stereolithography, it's only recently become practical for home use. Stereolithography has traditionally been very, very accurate and very high detail, but it has been very expensive. The printers themselves have come down in price. There are several that are available for less than $1,000 now for home use. However, the resin still is kind of pricey, and it's very manufacturer proprietary. So you need to use generally the manufacturer's resin unless you want to get into the realm of experimentation. Also, you tend to throw away a lot of resin every time you make a print. But the trade-off is the fact that if you're doing very detailed models like action figures, or like even something like a tiny gear out of a 3.5-inch floppy drive, we may all be familiar with those failures, SLA is the best way to do that. It produces the highest detail of reasonable home technologies. So SLS, this is still pretty much a professional technology, but it's been around for quite a while as well. SLS is basically laser 3D printing. A laser melts some kind of a dust or particle-based material to produce an object. You start with a vat filled with dust, and you focus the laser, and it moves around, and the object slowly appears, is basically the way it works. And it tends to waste a lot of material as well, but it gives you the greatest ability and flexibility with materials. You can use SLS and produce objects in gold, in iron, and anything you want. Anything a laser can fuse. And these are very high power lasers. You're just starting to see SLS become practical for home use. I was at the East Coast Rep Festival a couple weeks ago, and there was a guy doing a demonstration of a former commercial SLS machine he'd gotten at an auction for very inexpensive, and he brought it home, and he's been working with it, and he's had some success. But still an emerging technology. FDM is what I'm mostly going to talk about here, and that's what most people think of when they think of 3D printing. FDM works with solid plastics in the form of a filament, usually comes on a roll, and it takes that filament, it heats it up in a heat chamber within a hot end, and then it extrudes out the tip. And the tip is a narrow diameter. It can be as small as 0.1 micron in common use, or even smaller in specialized devices. And it basically extrudes it again like a tube of toothpaste onto your bed to form an object. It builds up layer by layer. The plastics you can use with FDM are really varied. There's amazing variety. I mentioned here PLA, PET, and ABS. Has anyone heard of PLA or PET? Okay, for those who have not, PLA is a plant-based plastic. It's one of the great advantages of it is it's fairly non-toxic, although we're not talking about any FDA food safe or anything like that, no matter what you may read. Nothing is ever food safe unless the whole machine that produces it is food safe, and whoever wound the filament produced it in a food safe environment. But generally, I feel safe enough making tools for kitchen use out of PLA. However, the problem with PLA is two things. One, you can't put it in the dishwasher if you make kitchen tools with it, it will melt. Two, like all 3D printing technologies, there are voids in them. So you have to be careful when you wash things. So it's great if you want to make measuring devices for water or things like that, or for dry powder, it's not such a big deal. But, for other uses, questionable. It is a very flexible plastic for most purposes. It's actually very much stronger than some of the plastics that people think of as being very strong, like ABS. That's ABS, the Apple IIc. That case is ABS. ABS is very commonly used in injection molding, and it certainly is very usable on home printing. However, caveats. One, Printing with ABS produces fumes that are definitely hazardous. You have to vent them. You do not want to print ABS in closed space. It's quite bad for you. 2, ABS is extremely sensitive to temperature change. So when you print it, you have to enclose your printer for the most part, or you've got to heat up your room. Because if you get a breeze while you're printing, your item is going to warp. You're going to end up with something that's not stuck to the bed, and your flat base for your case is going to look like a banana. PET is the other type of plastic that I use often. It is a sort of a halfway in between. It is not quite as strong as PET, but it's as PLA, but it's stronger than ABS. And it's also it's better as far as temperature resistance in the final product than PLA is, but not quite as good as ABS. So it's also fairly easy to print. It's also, all these 3 plastics are fairly inexpensive. There are other alternatives like nylon, like carbon fiber infused, there's wood fill infused filament. A lot of those infusions are actually PLA with some kind of a material added to them, wood particles or even gold particles or silver particles. Yeah, I think that's it here. Hardware. These are things you need that are not printers. Number one thing you need, of course, is patience. I put that all the way down the bottom, but that's the number one thing. Especially when you get started 3D printing, you're going to create a lot of unusual objects. They're not going to work the way you want them. Your printer's not going to work the way you want it to. You're going to get frustrated and you're going to want to give up. Just keep going through that. I went through that. I think everyone went through that when they started printing. It just takes time to learn the tools and learn what they can do. It is a lot easier than it was, say, 5 or 7 years ago. There's a big difference. Modern printers do things like auto bed leveling, which is a really amazing advance. You wouldn't think it would make a real big difference if your print surface is absolutely flat, but it does. If your print surface is not actually absolutely flat, things will fall off of it, and you can create horrible, horrible messes when things come loose. So, things you need. Calipers. I would suggest digital calipers. I have a link here in the presentation. I'm going to share that. I suggest calipers that are absolute origin, meaning you don't have to reset them, because otherwise you're going to forget to reset them. And digital calipers, I think, are easier to use than vernier calipers, but your opinion. You can do whatever you want. A ruler. Just get a really good ruler. I like metal rulers because you can't beat them up easily. Blue painter's tape is always handy. If you have trouble getting things to stick to your printing bed, you can put blue painter's tape on it, and a lot of things will stick to painter's tape. A lot of folks who've been doing 3D printing for a long time will suggest Kapton tape. I don't know is anyone here familiar with Kapton tape? Okay. It's orange stuff, orange transparent tape. It's heat resistant. It's quite often used in electronics. If you open up a laptop and you see tape around a heat sink, around a processor, that's Kapton. So it's readily available, and it's another tape that your 3D prints will stick to very easily, but it doesn't produce the best finished objects. I'll pass this around. This was printed on Kapton tape by the facility. And by the way, the model I'm passing around is its case for Nishida Radio's 2C VGA adapter, which I absolutely adore. PVA glue stick. That's just regular Elmer's glue stick that you probably used when you were in kindergarten. It actually will make both prints both stick better and stick worse. Sometimes sticking worse is a good thing. For example, depending on what is on your printer's bed, it may be something like, a piece of aluminum, it may be a sheet of glass. Those need help in sticking. However, when you get some of the plastic bed materials, things like PEI, which is what I use, it's basically a plastic sheet with some texture on it. Things like PET, plastics like that, stick entirely too well to PEI and will become permanently attached. So if you put down some glue stick, you just rub it on, make a horrible mess, before you start printing, your object will come off. So, it can be very helpful. Tweezers. All FDM printers drool. It's actually kind of funny. When you see the printer heating up, you get this little tail of plastic that's going to trail on. It will absolutely fill the bottom of your printer or the room that it's in or anything with tiny little plastic bits. They're everywhere in my house. It's one of the reasons I particularly like PLA, because I don't have to worry about my cat or my daughter eating them and being hurt by it. Putty knife. Putty knives are really good for removing things from printed beds. And again, I already mentioned patience. Printer suggestions. This varies really widely. These are just valid at this point, as of 2018. But I will suggest a technology. When you start printing, go with a Cartesian 3D printer, as in one where the head moves left and right, forward and backwards, up and down, or the build plate does the same. There are a lot of other types of 3D printers. There are Delta printers you may see. They look like the tripod over there. And they have basically in the tripod upside down, and then the hot end hangs from the top of the printer. And they can move really fast. And they have some great advantages for printing. They're much more complicated to calibrate. So leave that for your second or third printer. There are also what are called Core XY printers, which are cube, which have really amazing belt routing where the belts run all over the place and double back on themselves. They're neat. They can be high speed, but standard Cartesian printer is a lot easier. So I will recommend, first of all, the printer I have, the Prusa i3 Mark II, Mark IIs, Mark III. It's a really, really, really good, reliable printer with a heck of a lot of automation, so you don't have to learn. However, it's not cheap. It starts at about $600 and goes up from there to about $1,200. Second one, there's a Chinese printer. I know this might be controversial to anyone else who does 3D printing, but I actually do like this printer. I don't have one personally, but I have a lot of friends who do. It's called a Creality CR10. You can buy them on Amazon. They will be shipped from China, so you will have to deal with a Chinese manufacturer. But Creality has actually been a fairly good citizen as of late in the 3D printing community. There's a big problem with a lot of Chinese 3D printer manufacturers just ripping off other people's creations. Creality has been much better about this than the others. However, your mileage will vary. It's a foreign company. You don't have any direct access to them. There's a new company called Cetus. It's another Chinese company, but they're more legitimate. They're like fairly mid-sized Chinese company. They deal regularly in the U.S., so you can get service. They have a neat linear rail-based 3D printer, so it produces really thin, really fine, smooth finished objects. It's called a Cetus Mark III. It's about $360. And then Monoprice. I bet a lot of people have ordered from Monoprice. So they're the small printer called the MP Select Mini V2. It's about $200. It's also linear rail based. It's not quite as high quality of an object as the Cetus, but it's $200. It's a great way to get started. Micro Center actually has several very usable printers. They're all generally from a Chinese manufacturer called Wanhao, but they're supported by Micro Center, so you don't have to worry about them, and they start as low as $150, and they all work fine. This will definitely change over time, but this gives you an idea of where to start looking. The best way to find out what the best printers to use is to find out what other people are using and having success with. If you have a makerspace near you, go see them, go see what printers they have, go talk to the people in the makerspace and see what they like and what they've had issues with, or you might have a local printer manufacturer based on the makerspace. In Hammerspace, in Kansas City, is based a 3D printer company called Oni. So would be probably a decent printer to have if you live around here. CAD. So you have to draw your objects. Does anyone here have experience with CAD, 3D CAD in particular? Okay. Well, if you don't, it is a bit of a thing to learn, as you probably know. Depending on how you feel about doing your CAD work, whether you want to draw it, like a traditional vector drawing program, like MacDraw or something like that, or if you want to input coordinates, or if you want to write programs, you pick different programs. The first one I'm going to mention is called OpenSCAD. It's referred to quite often as programmer's CAD package. You can literally create loops and functions to create objects. It's kind of a neat thing. This is OpenSCAD. It's one of the objects that I've made. It's a badge case for a VCF Midwest badge this year. But as you can see, I don't know how well the folks in the back can read, but you see I've got functions here. It's actually a module, so it doesn't take any parameters. And you can see I call functions, and when I create an object right here, that's a cylinder. That's how you start. I have to give parameters. You see all those variables and all that math. If you think like that, and I do, this is really good. However, OpenSCAD is terrible for creating art. Really not functional in that way. But if you want to create screws or anything mathematical, OpenSCAD is wonderful. Next one, Fusion 360. A lot of folks may have heard of it. It's an Autodesk product. It is free, as in free to use, unless you make over, I think, what, $100,000? Is that right, Charles? Something like that.
I'm way under their limit myself.
Well, if you do what I do and make zero, then it's no problem. But it is a very powerful CAD program. It's fairly easy to get started on, and it has the advantage of the fact that there are a ton of tutorials out there on the web. There's YouTube videos, there's books, there's everything to get you started. This is Fusion 360. Let's see. So normally the way it works in Fusion 360 is you start, I don't know if you can see down here, I have a sketch down in the bottom of the base of this model. And this is the model that I passed around. So what you do is you figure out where all the openings and all the transitions and all the angles are, and you draw them in 2D first. And then what you do is from that, you extrude upwards. As you go up, you can create new planes anywhere you want and create a new sketch on top of that plane and extrude from there. So you can create some really amazing objects. And for the kind of simple stuff that mostly you want to do for vintage computer enhancement, works really easy. As I said, you know, there is a bit of a learning curve. It is more to get started than some of the others, but it's really, really, really powerful. You will have to deal with some bugs, though. I have Fusion 360 crash on me pretty darn often. Others, SketchUp is surprisingly popular. I don't know if anyone has used it. It used to be owned by Google. What do you particularly like about SketchUp?
Well, I'd like the. It seemed to be really popular, so that was one of the options that was brought up when I was asking around. But I still have an old copy of SolidWorks.
Yeah,
I usually
yeah.
make all of my stuff with SolidWorks.
If you have SolidWorks, that's fantastic. If you have any pro-level CAD or engineering tool, you can even make objects in Blender. I don't know if anyone here is a 3D artist. Blender is fully capable of making printable objects. No problems. Tinkercad's another AutoCAD made product, and it's entirely web-based, which is kind of nice. It also has the advantage of the fact that you create objects by dragging 3D objects onto into your virtual build area and combining them or slicing them or multiplying them wherever you want. So it's fairly easy to get started. The only main limitation is that you can only create 200mm cubic objects. Slicers. So this is something that is specific to 3D printing. You have to slice an object. As I mentioned as you go along, all the technologies we're talking about here, be it SLS, SLA, or FDM, they work by slicing an object into effectively infinitely thin slices. And then you build up that object, slice by slice by slice as you go. So when you have an object and you create it in a CAD program, you output it as an STL, as I mentioned, that's the standard file format. And then you have to take those STLs, which consist of triangles, and turn them into flat slices. That's what these programs do. These are the most popular ones that I'm aware of, and I've used all of these at least once. So the first one is Slicer. Second one is Cura. We have Simplify 3D, which is commercial paid for. Slicer, Cura, and Repetier are all open source, and I recommend them highly for that reason to start with. And then we have Octoprint. Octoprint is a little bit of a special case. It is a slicer, but it is also a program that you can put on a Raspberry Pi and make your 3D printer wireless if it doesn't have that functionality built in. So you'll probably encounter it no matter what at some point. It's a really neat piece of software. This is Slicer. This is what I use most often. You can see the back plate. This is from the 386 case that I built. You can see the ISO slots there. You can see one of the important things when creating objects and laying them out for printing is to put them properly on the build surface. I'll talk about that later in my tips section. But you can see the back plate is laid flat on the surface. What you're seeing here is, this is a preview, so it's showing these yellow are standard printing, standard layer printing. The red is a top surface. Something you don't see here, but you can't really see it in here, are supports. Supports are really important. Everything has to touch your printed surface. I'll get into more on that later. If it doesn't, you've got to put plastic underneath of it. You can't leave plastic hanging in the air, especially because it's hot. I'm sure you can guess it'll sag. So that's what supports are for. This is Cura. Cura is made by Ultimaker. They make some, I would say, prosumer 3D printers. Very well-made machines, but they're very expensive. But the piece of software they make, Cura, is open source, and it's really nice. Its advantage is it does supports better than most open source packages. This is Simplify 3D. It is like a semi-professional slicer. It's about, I think, about $250. It seems fairly popular. I've not used it much. I've not seen a need. And I'm a really strong open source believer. So, design. So if you think about it, if you've ever done woodworking or metalworking before, you already have the principles of making objects. Things that are specific to 3D printing you have to think about. Number one, I mentioned warping. So warping is caused by an object losing contact with the build plate. So whenever you create an object, as you saw in my previous example right here, you got to lay the object, the biggest flat surface you have, lay it flat on the build plate. That is the most important thing. So when you get an object from someone else that may or may not be in the right orientation, flip it around until it sits properly on the plate. If you don't have a flat surface, say you wanted to print, say a key from a keyboard, that's a very common use case. I've made a number of keys for replacement. I have a ZX Spectrum 128 that had some missing keys, and I printed keys for it. Also the power switch on one of my IBM PS2s. They really don't have any large flat surfaces. They're hollow objects. So what you do is you create a raft. Basically what a raft is the printer lays down a bunch of layers of flat plastic on the build plate that are throwaway, and then it puts the object on top of the raft, and that way the objects stick. Let's see, actually. Make sure if you have a heated bed, heat it up properly to the right temperature. When you get filament of any type, there's going to be a sticker on it. It's going to tell you, make the hot end this temperature, make the heated bed this temperature. If you don't have one, you can print PLA just fine without a heated bed. A lot of the lower end printers, including a couple of the Micro Center ones, do not come with a heated bed. So you can print PLA just fine without it. You just have to be a little bit more careful about prepping your bed. You have to make sure it's clean and then maybe apply PVA or apply some painter's tape or some Kapton tape. Warping is especially a problem with ABS. So again, as I mentioned this before, I'll mention it again. If you're doing ABS, you got to get the environment hot. Most ABS is done with printers that are enclosed rather than open frame printers. Or alternatively, if you have a room in your house you're willing to make 85 degrees, do it. You'll get much better prints. Or you can put your printer in a bag, but it's really, really, really unsafe. If you think about it, there's a heating element in that printer. Who knows what could happen? Who knows when that bag goes? And that is something I should actually bring up before all this stuff. Safety with 3D printers is really important. If anyone's been following the industry, there's a Chinese printer recently that's been a little bit famous for burning people's houses down. It's called an ANET A8. Basically what the problem is that when you have a hot end, and this is the case actually with heaters in your house, heaters in your car, normally there's a fail-safe on all those heaters where if the device can't see how hot the heater is, or it's not gotten any return from the heater, or it's drawing way too many amps, it will shut that heater down. A lot of the cheap Chinese printers do not have that. It's a silly thing. They're using open source firmware that makes it available, a firmware called Marlin in the most case, but they turn it off. Who knows why, but be very, very careful with that. If you buy a printer from a reasonable US company, this is probably not something you have to worry about. But what I will suggest are two things. One, keep a fire extinguisher nearby the printer. It's probably, I've never had to worry about that, but keep one. Make sure there's a working smoke detector nearby. And also, I suggest putting some kind of webcam, like the one we're using for this session. I watch all my prints. If I'm not in the room, I'm watching it on a webcam. So all those take care of the problem. You can go, Eric?
Yeah, I've actually seen where someone had a printer where all that stuff was disabled and a MOSFET melted down the hot end.
Yep. And even if nothing really bad happens, that's extremely annoying. You can create this huge mass of plastic that will actually destroy parts of your printer. Because large parts of 3D printers are plastic. And it's a bit of a tangent, but there's a good reason for that. The original creation of all this home 3D printing is via an open source project called the RepRap project. So the original objective was to make printers that, as much as possible, can replicate themselves, hence RepRap. And so therefore, that's why we make a lot of these components on printers with plastic. It also means that as you get better in 3D printing, you can and probably will upgrade your printer by printing new or redesigned components. It's a lot of fun. You could design your own printer entirely, and it's worth doing. It'll make your printer work a lot better. So again, fire safety, #1 thing to worry about 3D printing. Unnecessary overhangs. I mentioned overhangs already before. I don't have anything really here to show with, but if that model I passed around, if you printed it the other way, so the hollow side was down, the entire top surface would slip down, slough off, whatever, would hang down when you're printing. Because it's hot plastic, it's gonna run. So make sure you get it flat on the surface. Overhangs are something you're gonna have to deal with. Again, if you look at this Apple IIc, you'll see even if I put the large flat surface on here at the top of this computer on the build plate, it's still got rounded edges. That's okay. It's not a big deal. It's also got this indent where the floppy latch is. That's fine too. Anytime you're going to have that sort of an indent, if you work up to it and you have say a 45 degree or less angle leading up to it, so 45, 60, 75, 90 degree angle, then it's fine. Your printer can handle overhangs, those will work. But when you have it straight up and down, you try and put a cap on something, it's gonna sag. You can turn on supports, as I mentioned previously, and your printer will then put plastic underneath that overhang. However, then you gotta remove those supports. It can be a bit of a pain. Rotate your object, I already mentioned that. Just think about this when design. Go ahead.
Does it just automatically decide where the supports should go?
Yep, absolutely. On most slicers, you hit the button that says supports, it says OK. So all it really does is it slows down when it's putting in supports, and usually supports are like a half layer off everything else, and they're not nearly as dense as your printed model is, so you can usually just break them out. However, when you're making screw holes up into things, which is a very common thing with computer parts, it can be a real pain to clean out supports. So whenever possible, you should avoid them. There's all kinds of neat techniques I could get into to avoid the need for supports altogether. You can do things like, if you have a hanging object, you can put a one-layer support in your model. So if you're making a screw hole again, you can put a one-layer piece of plastic in there and you just drive the first screw right through it. Because one layer is 0.2 millimeters, 0.1 millimeters, something like that. Not strong at all, but it's enough to help your hole hold up. Properly set up your printer. That's a really, really important thing. Most people have problems with printing because their printers are not level. It's the #1 problem. So when you get a printer out of a box, when you get it from someone else, when you get it used, the first thing you should do is go through and calibrate the printer. Make sure your build surface is level. Make sure it's going to the temperature you think it is. Make sure it's putting out the amount of plastic you think it is, because it has a stepper motor. Is everyone familiar with what a stepper motor is? Okay, well, for the ones who are not, a stepper motor is just a regular electric motor, except for the fact that it's geared. So if you turn it and you feel it click, 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 hard drives and floppy drives use stepper motors, older ones. And that's what controls the movement. A stepper motor is not the same as a servo, which you may be familiar with. Servos are closed loop in the fact that they always know where they are. Stepper motors don't, but if you send them 10 pulses, they should move ahead 10 steps. So anyway, yeah, make sure that when that stepper motor turns and it pushes out plastic, it's pushing out the amount that you think it is. It's really easy to check. You just put a piece of tape on your filament, run the stepper motor 50 steps. You can do the math, determine how much plastic should have come out, make sure that's right. If it's not, change the multiplier. All the printers have a easy way to do this. All the major printers do. When in doubt, print slow. It's sort of counterintuitive. Everyone wants quick returns and objects to be finished quickly, but slower printed objects come out better. Their final, as in the final surface finish. Also, they have many less problems. Don't print at the most fine details unless you really need it. It's perfectly fine to print, especially large objects like, again, computer case, at 0.35 or 0.4 millimeter even layer heights. It's a big fat layer. You can also use a big fat extruder head. So I talked about 0.4, 0.2 millimeter diameter extruder head. They're ones all the way as big as 1 millimeter or more. And for a large object, that'll make your object print a lot better and a lot quicker. I said, again, good model design. And then these are BuildTech and PEI. I already mentioned PEI. That's the heated bed surface I use. BuildTech is another one. They're both plastic sheets you can put on your bed to help things stick. Reuse other people's objects. If an object is well rated, and again, I should have linked earlier to Thingiverse. Go look on Thingiverse. If anytime you're thinking about making something, make sure someone else hasn't already done it. If they have, take it and use it. I put all of my stuff on Thingiverse. I know Charles does too. They all have, it lists whatever the license on the object is and how you can reuse it. Most of those are some Creative Commons license, so it's pretty easy to reuse and modify it whatever way you want. But you can also, even if you don't like what someone else did, start from what they worked from. There's quite often a lot of comments on the objects you can see where people have said, hey, this doesn't print well, or this object isn't strong enough, or something like that. But you can take their object and modify it. If they give you the CAD file for it, it's really easy to modify. Quite often you'll see Fusion 360 files there, or OpenSCAD files there, very commonly available. If they don't, one of the great uses of one of the CAD programs I mentioned, Tinkercad. Tinkercad, you can fairly easily modify STLs, which are not normally something you edit. But Tinkercad can do it. You can add or remove objects. and make things work better. NetFab. Whenever you get an object and you go to print it, and all of a sudden your slicer gives you a big exclamation point or marks something bright red, it's probably because there are what are called broken triangles in the object. So that means whatever CAD program generated the object, made the final output, it didn't generate a proper solid object. There are holes in it. So NetFab can fix that automatically. In most cases, if you take an object that's got holes in it, you load it in NetFab online, upload it, download the resulting object, it's fixed. Fixes a lot of problems. You do have to look, because sometimes it will do strange things, especially if there are a lot of holes. I've had it rip a model in half. So you do have to look at it, but it's very useful. So here's some example projects. This is the badge. That's the VCF Midwest 6502 badge that I made the case for. I designed it in OpenSCAD. Again, as you can see, it's a circular object, a lot of geometric shapes in it, so it's fairly easy to build. And then it looks like this. That was actually my initial one. It's a little bit hard to see from here, but one of the things that you should do, again, maintain your build plate well, as I mentioned earlier. If you keep your build plate nice and clean, the surface finish on this is excellent. It's because I am hyper attentive to my build plate. Here's another one, that's the thing object I passed around, the shitty radio case. That's the 2C VGA adapter. That's what it looks like. I intended to bring it with me, but it's sitting in my house. There we go. There's the 386 board that I built the case for. And there's what the case looks like. I thought about bringing that, it was a little bit too big. But it was a lot of fun to design that.
Don't you need a big printer for that?
No, actually, I printed these all in sections. I don't know if you can see here, there's a lot of screws. Not everyone likes using screws. Charles, I don't think you use screws very much in your objects, do you?
I try not to.
I love nuts and bolts. Even if I don't have the right one, I'll even 3D print nuts and bolts to make an object. Usually you have to apply glue when you finish them so they'll stay. But one, I like the industrial look. I like old computers. I love nuts and bolts. And two, it makes your objects really strong. You can see here, I've got screws all along the bottom of here. And there's screws holding the floppy drive in the front and inside. You can hide them. As you can see, I've hidden a lot of the screws, but it makes a really strong object. Otherwise, yes, you're absolutely right. You would need a large printer. And an object like this would be really hard to print anyway. If you look at this, that would be a heck of a support. Because this part sticks out, you know, where the tabs on the top of your ISO cards are, you'd have to support that. You'd have a big old piece of plastic that you're just wasting on the back. And it probably wouldn't come out looking very well. So you got to print it flat on the surface. So one of the important things when making objects is to take them apart and make multiple pieces. So this is where most of my sources are. Wikipedia is a good source. There's actually a lot of links to really good sites on Wikipedia under 3D printing. And some information on simplified 3D. So how much time do I have left, Martin? 10 minutes? Okay. So first let's do some questions. And then if we get past that, I will actually bring up and show some slicers. Dr. Buggy?
I heard on the news that just in the last week the Supreme Court said that it's legal to make guns with 3D printing. Now,
yep.
Would a plastic gun actually work? I mean, with bullets?
It does. Usually once.
Would it get through the...
Yeah, literally. That's what it's designed for. If you think about it, does anyone read spy novels? I'm a big fan of spy novels. So if you read those spy novels, you would hear about spies carrying these microscopic little pistols that fire tiny bullets. They're real. If you ever go to the International Spy Museum in DC, you'll see some of these things. They'll come apart and they'll look like matchbooks or lighters or whatever. Even though they were made of metal at the time, they would only fire once. As soon as you fire it, it's going to come apart because they're not thick enough. But same with 3D printing. Believe it or not, you can actually print a surprisingly strong object. I was talking to Forrest earlier about replacing one of the supports in a 2C. The original object was made of nylon. I can print in nylon. I can print with 100% density. It's one of the things I didn't mention. When you print, normally you don't print an object that's solid plastic. It wastes plastic, and plastic printed objects are really strong anyway. So if I printed a 100% density object and I try and fire a low velocity round, absolutely will work. Yep, and it's kind of an important case too. Whether you believe in firearms or not, there has been a big discussion about whether it's legal to make an object of all kinds of object types, because there's all kinds of things I can make. I can make a plastic knife that's quite sharp. You have to think about those things. And you have to think about whether it's more important to be able to make or it's better to keep people safe. And it's an important discussion. I'm glad you brought it up.
Would a plastic gun get through the X-rays at an airport?
Metal guns do too, sadly. TSA is really bad. If you read some of the articles, there's a journalist who accidentally brought a .45. That's a big, heavy gun. So a World War II officer's gun. He brought it through security. It was in his bag, and he'd forgotten about it. He turned himself in when he arrived, and he nearly went to jail anyway, even though he turned himself in. But they did not notice. It was in his bag, on his back, as he walked through an X-ray machine. It's a big old piece of metal. Question?
With photocopiers,
Mhm.
they require to embed a serial number.
Yep.
Microscopy. Is there anything like that for the 3D printer world?
Generally not. Professional level printers sometimes will embed marks in them. You can make that happen if you want. But almost all these slicers that I showed you are open source, with the exception of Simplify 3D. So most in the open source community would consider that to be backdooring the user. Usually not a good practice. Other questions? Go ahead.
What do you do about post-processing with regard to if you don't like the layering effect of the texture?
That's a really good question. I didn't bring that up at all. If you look at a finished product, again like this 2C, it's actually got a really nice finish on the case. Obviously this was injection molded, but depending on how you print your object and depending on how it was sitting in the build plate, you're going to end up with a different finish. The part of your object that sits on the build plate is going to have by far the best finish, assuming your build plate is clean. The other sides are going to be a little bit rougher, and you're going to see, like Peter said, you're going to see layer marks down the side. So depending on your plastic is the answer to your question. I have, because I mostly work in PLA, I sand. That is the easiest thing. You can sand and fill with putty. It's really easy. It generates dust. You got to wear a breathing mask and all that. So it's worth considering, but it's not a hard thing to do. If you're working with ABS, you can use other things. You can do what's called vapor smoothing. Charles, have you ever done that?
No, I don't actually do any of my own 3D printing. I send all my stuff out to Shapeways.
There's actually, that's a good point. That is something absolutely valid. If you don't want to own a printer, you can absolutely use Shapeways. I think I mentioned them before, but they can create things in quality that you cannot replicate. They're kind of expensive is the biggest problem. If you're doing what Charles is with a business, it makes perfect sense. He would never want to print those objects out because he'd have to hand finish or paint or whatever. And there'd be a variation in quality. Even if you're meticulous about your objects like I am, still they vary a lot. So it wouldn't be worth it. It'd be way too slow. You'd end up with 50 printers in your house. It's not worth it. Use Shapeways if you're thinking about making a lot of an object. Question?
Where would you recommend someone get sandpaper of the quality required for finishing plastics?
Home Depot, Lowe's. Seriously, you can just get all the grades. Just if you want a really nice plastic surface, the only thing that's special about sandpaper is you're going to gum it up with plastic. So you're going to throw it away pretty often. So don't buy really special sandpaper. Just get a regular sanding block. If you get a sanding block that's got a flexible surface, it'll contour around your edges. If you have one with a really hard surface, you'll get a better flat finish. But just buy various grades of sandpaper, all the way down to 200 grit.
I also find that I live in an area that doesn't necessarily have a Home Depot or a Lowe's.
Okay.
Automotive parts store.
Yeah, yeah, absolutely.
Very refined sandpaper for finishing automotive parts, which often are plastic, that works excellent.
And that
it's very easy. You don't think about going to the automotive parts store for maker space stuff, but they'll sometimes have the same sort of tools for performing that sort of fine detail finish work.
Absolutely, and you can do other things that are useful there. Automotive paint sprayers. Thank you, Mark. Automotive paint sprayers are really useful for finishing your objects if you want to paint them. All those techniques, all the techniques that you watch Auto Bodyman do, if you watch on YouTube, they're great finishing techniques for plastic objects. Any other questions? Well, I guess, 3 minutes left?
I actually have a question.
Go ahead, Martin.
You mentioned that some printers produce better results for small, fine detail objects. Do you have any samples with you we can play with after?
No, I don't. But what I can do is I can send you some, or I can send you links to them. That would be SLA. That's usually what I suggest when you're talking about really fine detailed objects. Again, like floppy drive gears and things like that. You can print them with FDM, but you have to print them with a really tiny nozzle, really slow. So, and normally when you're printing objects like that, the physical strength advantage that FDM has doesn't matter so much. because the fine detail is a strength all of its own. You may know that when you're printing a gear, it's really important to get the profiles on the teeth exactly right. The most important thing is not so much how strong the plastic or the metal is in the gear, which is why you saw Apple or Chinon or TIAC use plastic gears in their floppies, but it's how well they mesh. So even if you have brass or steel gears even, if they mesh poorly, they're going to grind each other's tips off. You think about it, they're going to run into each other. And as you do this over and over and over again, they're going to beat each other up. With a bunch of metal or plastic parts in the bottom. But if they mesh really nicely, again, if you print something in SLA, it meshes very fine, can last a very long time. Go for it, Charles.
If anybody wants to see SLA or SLS laser-centered parts to comparison, I have a few pieces that are with me, so you can see the comparison.
Perfect. Cool. Go see Charles.
Okay.
Yeah, absolutely. And it's really fun to play with the technologies. If you get into 3D printing, you're probably going to end up with an SLA printer and an FDM printer and a Delta and I just as much as I love vintage computers of all brands, I may be a little bit heretical, but I love all vintage computers. I love printers too. I like making them and modifying them and repairing them and all of it. It's incredible fun for me. I guess that's it, because I think I'm about out of time. Thank you. Thank you very much for the cooking.
No problem.
Yeah, come see me later if you have any other questions.
Next up will be Rob McMullen in a couple of minutes after he sets up.
Did it work okay?
That worked out beautifully.
Good. I guess you don't need my phone.
Worked really well.
Good.
And this mic didn't fritz out on you, so good.
Maybe I'm not metal.
Yeah.
Oh, so something I forgot. Does anyone here have a sheet of radio to CVGA adapter? Does anyone own one? I'm the only one. Wow. Do you want the case? I'll give it to you. The case that I had made sitting right there. It's yours if you'd like it. If you want a case for it. And pass it down. It's all yours. It was meant to give away. Thanks.
I'm at the hit the input switch button.
It's the same in the
Yeah.
Oh, mine is not plugged in. Where's my glasses?
Yeah, there's not a plug in yet.
I can't move that. Okay, let's get this. Should I take this off? Okay. I've got a nice clip on there. It's probably good. And then put this outside there. So just flip that on when you're ready. I'll introduce you.
Okay, Rob McMullen's going to tell us all about fast HDR font rendering on all machines except Atari.
I have to warn you, I have no costumes to change into today. Oop, there we go. Oop, almost. Now it's off.
The light doesn't stay on, just...
Oh, okay. All right. Am I coming through the speakers?
Yes.
Okay, great. All right, so this is the game I made last year for Hackfest. Start it up here. So it's a clone of Amadar. And in the run-up to the Hackfest, I learned a lot about Apple High-Res. Well,
I dare say I know more about the Apple II than I know about the Atari. Well, that's not true. But let's see if I start here. But I guess, well, I will wager against anyone in this room that I know as much or more than you do about all the help that Apple gives you in high-res graphics in the Apple ROM.
Tell us about it.
It's nothing.
Squat.
Yeah, diddly. So it's you know, I wrote the game. It's true. I would have done it differently if I had done it on the Atari. You know, because it has a graphics code processor and hardware sprites and hardware scrolling in 256 colors and vertical blank display list interrupts. Hail, Minor, DeCure, and Neubauer. Hallelujah. Have you played Atari today? No. All right, well, say 5 Hail color palettes and see me later. Okay. So I didn't cheat in anything. I wrote this in 4 days, but there's some tricks and stuff that I will show you. So let's run this again, but this time we're going to look at the text page as well. So this is a text game. So that's how I was able to do it in 4 days, because even though it looks like it's high res, coming from the Atari, I am used to like redefining character sets, so that's essentially what I used without hardware support. But so this all it's doing is tracking what's going on the low res page. I'm keeping like some sub character information about pixel position of the individual sprites, but that's it. I mean, it was easier than it. Well, it wasn't easy, but it was easier than it might seem looking at a high-res game. So, and in dealing with high-res, I learned a lot of stuff, and so I'm going to share that stuff with you guys today. So what are we talking about? So so what I did is I wrote a font renderer that can, you know, the sprites themselves are made using a modification of Quinn Dunkey's sprite compiler. But all the characters are rendered with a font renderer that I wrote. Okay. So first, I wanted to show you what we're up against. So this is let me show you. Well, first let me show you what if you were to draw a font in BASIC, what that would look like. So I've already loaded the font in memory, and so I'm just looking for where it is. I loop over the X position to write a whole line of stuff on the screen, and then poke the stuff right to the screen. So I'll just run that. And it's not quite arcade speed. So yeah, so if you extrapolate this out, I have a whole bunch of stats here. It takes 120 million frames to draw, or 120 million cycles to draw a single frame, which is about, what, 7,050 actual NTSC frames, or, yeah, a little bit too long. 117,000 milliseconds, so that's not game material. So if we have to go to machine language, so I'm going to show you, this is a sort of a basic clear screen routine. So I just have some boilerplate stuff here. Everybody see the cursor? And this, what I'm doing here is I'm just looping 64 times. So I'm drawing the full screen 64 times. And then exiting. So that's the boilerplate for all these 4 clear screen routines is the same. So then I will look at the screen itself. So just loading the pointer to the first high-res page, and just looping using an indirection pointer and going until it's at the bottom of the screen. So let's run that one. Type. So instead of clearing the screen, I put some characters so you could see the difference in how it's drawing. So this is running 64 times. And oh yeah, there's something messed up with my Apple one, so it's running a little slower than normal. So that one is about 90,000 cycles, or it takes like 5.3 frames, NTSC frames to draw a single full screen. So that's like 88 milliseconds. The good thing about that routine is it's only 26 bytes long, so if you're hurting for space, that's okay. As it turns out, if you add just 3 bytes, you can get this one using some self-modifying code. So all it does is just change this to whatever the current line is, and then what is that? So let's run that one. And it crashed. Great. Wouldn't be a demo if it wouldn't crash. And again, this Apple, I can't figure out why my Apple one is running slow.
It says 50%, exactly 50% speed in the title bar.
Oh, I don't know.
It
Maybe.
might be under the little joystick button. No, no, that's authentic. You can do double. Oh, that's 50% scan lines.
Well, I have another emulator we can use, so I'll change. So that's slower than it would be normally. But that's all the demo does. For all these demos, they just do exactly the same thing. Call it this other emulator. This one, sorry, it cuts off the bottom of the screen, so you won't be able to see what I'm typing, nor will I be able to see what I'm typing. So where were we? All right, so that's real speed. And so that one's self-modifying code takes 82,000 cycles down from 90,000, 4.9 frames and 81 milliseconds. So getting a little faster. Let's go back. So if you get a little more creative, you know, I didn't really explain the screen structure, but it's kind of odd. Probably most everybody knows it here, but let's see. Let me just put it up here real quick. So this is the high-res screen. Nope, find the game. Let me move to the high-res page. All right, so if I highlight these bytes, you know, the first 40 bytes are going to go on the first line, then the next 40, third of the way down, then third of the way down. And it skips back up to the top, 8 lines down. So that's the structure of the high-res page. That's what we have to work against. All right. Back. All right, so that was the self-modifying code. If you can, now I didn't write this code, but Martin has been quoted as saying, I can't write that code, but I can write code that can write that code. And so this is so what I'm doing here is I'm just listing every single column, every single row on the screen, marching across by columns. And you see all these, so there's 192 stores. And if you run that, oops, that's the wrong emulator. Fast clear. It's much faster. So that gets it down, from 82,000 was the last one, it gets it down to 38,000.
And that's actually drawing the same thing because you can't even see that there are letters there.
Oh, sorry, this is the clear screen option, so I'm just drawing bytes to the screen. Okay. I'm not drawing fonts yet. I'm just kind of showing what we're up against is how much data we have to move. Yeah, so 2.3 frames, 38 milliseconds. It's bigger, it's 590 bytes, 587 bytes. And then if you have 23 kilobytes to spare, you can do something totally nuts, which is that. So that's 7,680 store statements.
You can just store every byte?
Yep, store every byte. So this is the fastest you can possibly go. So it's right. It's not that much faster. It turns out it's 31,000 cycles instead of 38. So and it's 23K. So clearly that wouldn't be used practically, but that's the limit. That's as fast as we can possibly go. So we won't be able to get near that speed with the fonts, but we're going to see how close we can get. All right, we've already seen basic. We don't need to do that again. Let me show you the font routines. So again, I've got some boilerplate code that all the code shares. So it sets the high-res screen and jumps to the driver 64 times again. But this time it's going to call a font drawing routine. And so I put that in the front of the code and then I link it with, let's see what we got. This one. All right. So this is kind of a super naive implementation. So you have two pointers, a font pointer and the pointer to the screen itself, and just looping over and over and adding. Sorry, actually I have to add 4 to the high byte. And then the font, it's just the fonts are 8 characters high, so it's looping 8 times for that. So this one is about the slowest, besides basic. Could have made shorter titles. So that's not super fast. So to do one frame takes 437,000 cycles, which is 26 frames. So what, 427 milliseconds, almost half a second to clear each screen. So that's not fast enough. Certainly not fast enough for a game. So this is the routine out of assembly lines. So chapter 31, if you've read that one, which I did a lot, trying to learn how to write this game. So it's two pointers, and he's using a little trick of some pointer math, so you don't have to add stuff to the second pointer. So if we run this one, not much different. So down from 437,000 to 390,000. So this takes 23 frames, so 382 milliseconds. So it's not, we can do better. We can do better. So this one is about the fastest I came up with by myself without doing self-modifying code. So what we're doing is, again, we're storing, using 2 pointers and looping through. It's not trying to think what the major difference is here. Not much. Well, as it turns out, won't be much difference in the speed either. It's not appreciably faster. It's from 390,000 down to 375,000. So from 23 frames to 22 frames to draw a single frame. 382 milliseconds. Now we start to get into some fun stuff. This is self-modifying code, so we're only using one pointer now. So in the setup here, you put the font info. Where's the? Yeah, so here it is. So you load the font pointer. You calculate, based on the character. You shift over because it's each character is 8 bytes after the other. Sorry, I should have showed you the font. Let's see. So yeah, you load up the font in the self-modifying code, and then you use a pointer for the screen location. Run this one. A little faster. So this one is down to 320,000 cycles, or 19 NTSC frames to draw one whole screen. 313 milliseconds. So then we have a crazy one here. Using the basis of Quinn's font, or Quinn's sprite compiler, I made a font compiler. So what this one does is, instead of looking at a data table for the fonts are encoded in code. So character 0, it loads up a character, stores the pointer, adds 400 hex to get to the next one, loads the next byte, stores it on the screen, adds 400 to the screen pointer. The problem with this one, of course, is the sheer size of it, and that you can't short circuit this. There's no way to get I'm trying to say. Let me run it while I'm trying to figure out what I'm doing here. This is long. This routine is 12K, whereas the other routines, they've been about 150 bytes. They don't include the font data, so you've got to load 150 bytes plus. I'm using a 120 or a 1024 size font. So we are getting faster. This one, so from 320,000, we're down to 211,000 cycles, which is 12 NTSC frames to draw one screen, or it's like 200 milliseconds. And surprisingly, we can actually do a little bit better than that. Or I was surprised anyway. I don't know. I didn't see this anywhere in the literature. I'm sure I'm not the first person to discover this. So what this is another. The font is not compiled in here. It's still looking up at a regular font table, but instead of the fonts being laid out one character, so consecutively in memory, so you can see the font. This one is laid out. The first byte of each character is in a big string of 256 bytes. The second byte of each character is in the next string of 256. So I call it a transpose of the font. So it's when you look at the byte, when you look at the hex of the game or whatever, you can't tell it's a font. It just looks like a bunch of random data. But if you lay it out this way, what that allows you to do is you set up a jump table for each row. And in it, so this is just jump table stuff. You just figure out which row you're going to go to, then jump to it, and the table data is here. And then this section of code can draw any character on row 0, whereas the previous, the compiled font could not draw any character. You had to compile a particular character into each little spot. So if you look down, this can draw any character at row 1, and so on. So let me run this one. That's my dumb long file names. I can't remember what it was. I guess the title kind of gives it away. Yeah, so that gets us from 211,000 down to 129,000. So that's 7.5 frames. Compared to, let's say, like the assembly lines one is 23 frames per second. So this is almost 3 times faster. The cost is about 1,500 bytes for the function, and you have the 1024 bytes for the font. But that's 3,000 bytes versus about 2,000 bytes for the whole font. But it was fast enough that allowed me to do the game. And all this code is up on GitHub, and I'll put a link up to it. I'll send it to the mailing list. But that's it. Have any questions?
What version of Omnivore were you running? Because do you have an emulator?
I do, yeah. This is a new version. It's not been distributed yet.
Aww.
It's coming. It's just a lot of work to change stuff that in the old version, the new version architecture it's very different. When you change one thing and you realize you have to change something else in order to get this other function. It's just cascading down. So, but yeah, it's you can do multiple views of stuff. You can you want to have 2 views of high-res page 1, you can do that. Well, this right now is pointing to a different segment, but of course it didn't change. But yeah, you can try to change the data, and you can change multiple things at once. But yeah, I'll release this sometime soon. Any other questions? Charles?
How many of these improvements that you're showing have you done since you did your Hackfest entry last year? Any updates to what your Hackfest was?
No, this was in the Hackfest entry. So that's the fastest I found. So I did this, yeah, January, March last year. Any other questions? Okay. Excellent. So I'm going to leave this kid with you.
Thanks, Rob. Next up will be the last presentation of Kansasfest 2018. Kevin Savitz will take us out with the first Laserdisc video game in about 5 minutes.
Is it?
So let me just make sure I understand. I'm a game developer, obviously, and I find bugs that are, proportional
Hi. Hi. I'm here to help if you need it.
Great. I need to switch back to the other.
Okay, the other HDMI. Got it.
Okay, we're on the white one.
Thank you.
Which one would you like? Excellent.
Great. And while these plays go on, am I able to look at the contents of memory and registers and
I saw him with the microphone earlier. It's like corporate thing again.
Oh, so I think I got it. So at any point in time, I can go into the logger and see, okay, actually, that's not structure. I have to go back and replay.
Jump back into replay. What actually you want to jump in and I have the option
Definitely second
Are we on time?
A very different sentence.
Check you brought your own mic.
Well, that's, yeah. So if you put this to... And then this one's, yeah. Oh, can you change the camera so that it gets both the screens?
That one always gets both screens. I'll change this one so it also gets both screens.
Okay. Well,
I'll make sure.
Yeah, okay. I usually tighten it up. So
you
so,
do? Okay.
Yeah.
I'll check it. Okay. And yeah, so just turn that on right after I introduce you.
Okay.
Okay. Oh, sorry about that. Kevin's here to tell us about the first Laserdisc video game.
Hello. Good afternoon, Kansasfest. I would like to start by having you watch a 1-minute movie trailer.
Get ready for the thrill of your life. Now, Universal plunges you into a mystery at the speed of sound. Roller coaster.
That's 2 accidents in 1 week. Who's putting the lid on this? The police?
A recording from a stranger.
Get on the right, Harry.
A drop in Virginia.
Harry,
Yeah.
remember what happens when you don't follow directions.
And a man in the middle on the ride of his life. life. They're over the lift. It's too late to stop them now. Let's go.
All right. This presentation is called The First Laserdisc Video Game. What was the first Laserdisc video game? It might have been Dragon's Lair. Maybe that's the first one you heard of, but no, it was not. Because Astron Belt came out the year before. Astron Belt was shown at the Music Operators Association show in 1982. And you can you start researching this stuff and you will find people on the internet arguing about, well, technically it wasn't released until 1983, but it was shown at this show in 1982. However, there was a different show in 1982 where earlier, 2 months earlier when they released Quarter Horse. Quarter Horse was probably, I believe, the first arcade game that included a Laserdisc. I'm going to take a tangent to tell you something interesting about Quarter Horse. It has nothing to do with any of the rest of the talk. Quarter Horse had a Laserdisc in there that could show 60 minutes of video. So there were 60 one-minute races, horse races that you could watch in the game. You would bet, not real money, you would bet on who you thought would win. You'd watch the race, and then you'd see what happened, and you'd win or not. They used stereo to have a left track and a right track that had different announcers with different names for the horses and stuff. So it seemed like there was 120 different races on the disc. Kind of cool. But the first version came out, like I said, in '82. Versions of that game remained in production with Laserdisc till 2012. And last I heard, that article said then they switched to solid state versions, and it might still be being made. Anyway, so that's Quarter Horse. Kind of interesting, nothing to do with what I want to tell you about. What I do want to tell you about is about Adventures in Videoland, which is the first Laserdisc video game, which was published as a type-in basic listing for the Apple II in Creative Computing magazine, the January 1982 issue. It arrived in people's mailboxes late in 1981, putting it well before the early in 1982 date of Quarter Horse. Apple II wins.
Yay.
Yay. This game was written by David Lubar, who is he was a staff editor at Creative Computing magazine. And he has an interesting story if you read the article. Basically, David All said, I want you to write a Laserdisc-based video game, and David has a story about how he was just like, no, I don't want to do that. How long do I have? David's just like, 2 weeks, and David's just like, hell no. It's a very interesting story. And then, of course, he ends up at David's house, hooked up to the AV system, coding this game. Here's the cover of that issue. It also appeared later, a couple years later, it was reprinted in Big Computer Games, which was a compilation of games from Creative Computing magazine. So the official name of this game was Adventures in Videoland, and I call it Roller Coaster because that makes more sense. And what it was a type-in, basic, simple two-word text adventure game that used the first side of the first disc of the Roller Coaster Laserdisc. The Roller Coaster Laserdisc, here's the cover of it. There's one of the actual discs. It was on 5 sides on 3 discs because this format that they chose to use, or that was available to them at the time, could hold 30 minutes per side. And you didn't want to, it's not that it's a 2.5-hour movie, but you don't want to cut a scene off in the middle, so sometimes they have to move stuff to the next disc. So it's a lot of getting up and flipping and pee breaks, I think, when you were using Laserdiscs. Tangent number 2, let's talk about Roller Coaster a little bit. It came out in 1977. It starred George Segal, who I've heard of, and Timothy Bottoms, who I hadn't heard of, but Carrington had. He was very excited about that. And it was Helen Hunt's first movie. It came on the heels of a bunch of disaster films, Earthquake and Airport and Towering Inferno and things like that, which was kind of what people were into at the time. And then a few weeks later, a little movie called Star Wars came out and changed the direction that moviegoers were interested in forever. So this movie didn't do horribly, but it did okay at the time. Its timing maybe could have been better. It was released in Sensurround, which basically meant that you go see it in the theater, and they'd have 2 or 3 big old subwoofers that were keyed to a special track on the audio track, and it would rumble as the bomb went off or as the roller coaster went by, and that sort of thing. Roller coaster. Now, to connect it to the Apple II, it used a Aurora, later called Aurora OmniScan Laserdisc interface, which was a card that was plugged into your Apple II, that then plugged into your Laserdisc player, and allowed the Apple II to control the Laserdisc. Laserdisc players at that time didn't have serial control, so this thing actually plugged into to the Laserdisc player through the wired remote control port. And it would basically emulate a remote control. If you wanted to jump to a certain frame or pause or whatever, it would just set, the Laserdisc player thought it was talking to a wired remote. Originally cost $275. Later, I found it dropped to $250. Here's an ad for it. Only worked with the Pioneer VP1000 Laserdisc, which is a beautiful machine. Look at that baby. Look at that baby. I just want to press those buttons. Isn't that beautiful? Man, it's a good-looking machine. But, there was a bunch of many other Laserdisc interfaces available. I mean, here I have a list of, maybe 20 different Laserdisc interfaces, and a lot of them work with the Apple, a few work with the Atari. You can get them work with CPM and IBM and many other systems. So there were a lot of them. It was a thing for a minute. So like I said, it was you could hook it up via the remote control port, which is probably became later not the most efficient way to do it. I asked David Lubar, who's on Twitter and is a nice gentleman, was this the first game? Is my whole premise of this talk wrong? And he said, I've seen the game credited as the first Laserdisc video game. I appreciate that. I'm not really sure I can take much credit other than carrying out a coding task that was handed to me by my boss. Dragon's Lair feels more like an actual Laserdisc-based game. The Roller Coaster Project was really more of a proof of concept. I think the term, one of the articles I found, used was the use of Laserdisc cutscenes, which is closer to what he made. Either way, it's kind of cool to be a tiny part of one branch of gaming history. On the other hand, I'm nearly 100% certain I was the first person to put Macaulay Culkin in a video game, which was Home Alone for the Game Boy. So, a video disc primer. Three main kinds of video discs. First, we'll talk about capacitance electronic disc, CED, which was RCA standard. Here's what you need to know about it. It was a record album for video. It was literally a vinyl disc with a needle that scratched on the disc and played video on your screen. It was not a laser disc, but it was a video disc. And it had a constant angular velocity of 450 RPM or 375 for PAL, and each rotation contained 8 interlaced fields. That's 4 full frames of video. And because of that, you couldn't do freeze frame, you couldn't do slow-mo or anything, because what you want to do for that is to just hang out on one track and just be there, and it couldn't really do that with 4 frames per track. CAV, number 2, constant angular velocity. This is called standard play. All DiscoVision discs are standard play. They always run at 1800 RPM. One rotation takes 1/30th of a second. There's 1 frame per track, which is important for us soon. Each side contains 54,000 tracks, so 54,000 frames works out, I think, to exactly half an hour of video. Please don't at me about that. there's individually numbered addressable tracks, so you can search to a specific track and start playing from there. Packing density is more tighter on center tracks because they're smaller. There's freeze frame and slow-mo and jump to frame number. Now later on, having a movie take up 3 discs was expensive and expensive to produce, and people probably didn't like getting up 4 times during the movie to switch discs. So a little bit later, they came out with constant linear velocity or extended play disc. You could get up to 1 hour of video per track. I'm sorry, per side. You can still do 2-sided discs, which is how the horse race game worked by having 1 hour, because they didn't have to freeze frame or anything for that game. So 1 hour per side, and no freeze frame or slow-mo. You're trading storage for those features. There was actually another format, an offshoot of CLV. Read about it on Wikipedia. I'm not getting into it. It doesn't affect us for this game. Tangent number 3. Let's make a video disc, shall we? Let's go back to 1985 and go, I'm going to make a video disc, right? Your 1985 mastering costs are at least about $2,000, maybe $1,500 if you go with the cheap thing. Going 2 sides, you're getting up to $2,500 or so. And your cost per disc, let's say you want to make 1,000 Pioneer discs using the CAV format, you're talking $15 a disc. This was not cheap. So I decided I wanted to revive Adventures in Video Land, aka Roller Coaster. I got a text from a guy saying, yeah, you're not at the Retro Computing Swap Meet. Why aren't you here? And I was just like, I didn't know it was today. And I had nothing to do that Saturday, so I hustle out there, and I see my buddy Marcus. Is Marcus here? Hey, Marcus. And Marcus has a pile of Laserdisc players and stuff he's selling, and my mind just randomly, the wrong electron went off, and I thought of this game, and I'm like, huh, that's funny. And I'm walking around, and I'm buying plotters and doing things, and then I see a guy who's selling Laserdiscs. And I was just like, fine, I'll ask the guy. So I say, hey, do you have Roller Coaster? He's like, I do, I don't have it with me today, but I can get it for you. And I decided to see if I could revive this game. So I needed a Laserdisc player. I needed the DiscoVision version of Roller Coaster. It later was published in the other format, but I knew that I would need to jump to has freeze frame and stuff. I need an unusual serial cable because I'm not going to do it the weird way with the Aurora. First of all, I could not find an Aurora interface, video disc players have gotten better. They now have serial, modern, right? Laserdisc players have serial interfaces. So I figured maybe I can control it just using the Apple II's serial port. And indeed, the Laserdisc player that I got does have one. It's an unusual number of pins, not unstandard, so I had to buy an unusual serial cable. That wasn't too bad. And then, of course, finally, I need the basic code in the Apple II. I thought that'll be easy. It'll be out there somewhere. And of course, there were scans of the magazine, which I think I did a decade ago, or several years ago, and there's scans of this book, which I know I did. But nobody had this game. This game was not anywhere available online. So I typed it, and 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 I debugged it, and I put it on GitHub, so no one's ever going to have to do that again. But this version was meant to work with the Aurora interface, and I had to then next modify the program to work with modern serial interface, which I researched a lot, did a lot of reading, and I learned that how easy it is to access the serial interface from AppleSoft Basic. First, I learned that I have 2 Super Serial cards, and neither of them seem to work properly. Then I switched to the Apple IIc, because it has built-in serial, and I learned the whole thing about using IN number 2 and PR number 2 to access the serial port. As far as I'm concerned, all lies. All lies. So just as I was about to give up, I found a Usenet thread from God knows how long ago, and they were talking about how to access the serial port using poke, and I ended up bit banging the serial chip, and I got it to work. So I modified the game to work with a modern serial interface. And that is also available on the GitHubs. So yeah, I moved from this bad boy, the old Pioneer, to this bad boy, which is the one that I bought from Marcus. Thank you, Marcus. Because it has there's our serial port on and back, like that. This is the list of Pioneer players that have that feature. I believe I'm using the 4200 or the 2200, I don't know. So there is the URL for the GitHub. I wanted to bring my Laserdisc player and demo this for you, and that didn't seem like a good idea. Laserdisc players are old and they're fragile, and they're not terribly reliable. Laserdiscs have a lot of problems. What doesn't have a lot of problems are DVDs. Did you know that Pioneer makes a DVD player that's serial controllable? What? That uses the exact same protocol as the Laserdisc player? I found that out. And so I got a Pioneer Laserdisc player. That's what I brought to Kansasfest in my checked luggage. They also, and I've not done anything with this, I also learned they have a Blu-ray player that is serial controllable and also uses the same protocol. Pioneer is awesome. So I need to change the input to my Apple PC. Wait, give that a second to warm up.
It doesn't get super bright. Just so you know.
Okay. So, I'm going to show you the game Roller Coaster. 2 people probably have played this in the last 30 years. I tested it extensively. Carrington played it the other day. His playthrough will be on the Eaten by a Group podcast. His opinion of it will be on the podcast. I also have made a YouTube video of my playthrough with the Laserdisc version, but we're going to see the DVD version. What is your first name, Gavin? You've just received an anonymous tip that a bomb has been planted on a roller coaster.
That's awesome.
You are called to investigate and fly off to stop the saboteur. On his side, he has the brilliance of an insane mind and an aid of allies who are determined to see that you fail. On your side, you have cunning, training, and dedication. You have infiltrated the park with the knowledge that the saboteur will strike sometime tonight. All you need to do is stop him. Now, some of the benefits of DVD. First of all, we've got full screen, higher def, way better video than we had on the Laserdisc. And also, now, we have access to the entire movie, not just the first 26 minutes. So this game could easily be expanded to have more rooms and more things and a way bigger game. Because basically, David had to work a game around just a few thousand frames of video. Also, if you were so inclined, you can't burn your own Laserdisc today. At any price, but you can burn your own DVDs. What could you do with that? I had some ideas. You might put a bunch of Apple commercials on, burn them all to DVD, and you might have a menu that lets you choose and watch different commercials from different eras. Or you might make a game. Did I tell you that these things you can link? You can have 2 and you can link them and control different things on different ones. So how about a game where you have people talking to each other? You can choose what phrase to say or something, and you can have 2 people talking. Or I had the idea, it would be absolutely terrible to have a software automatic Carrington. We could record him saying 1,000 different words, and then you could have him, I don't know. The possibilities are finite for sure. Let's continue the game. All right, and it basically tells you how to do a text adventure. It's all 2 words. So press any key to begin. May luck be with you, Kevin. You're in the midway, which stretches to the east and west. A restaurant is to the north. This location contains nothing. Visible exits north, south, east, west. You can see we have a picture of the midway. Isn't that nice? In David's original version, interesting because that player through that interface, you could jump to a frame and you could play. You could also you would watch both the video and the screen and the text on the same monitor. And you could choose when to go back and forth. I don't have that capability using the serial interface, but it would basically switch back and forth on the same screen. Kind of neat. But a feature that we can do that other interface couldn't do is that we can specify a starting frame and an ending frame and have exact frame-to-frame reproducibility of exactly what I want shown. The old Aurora interface with the old Pioneer thing, basically he started from a frame, he had a for next loop to count an approximate amount of time, and then he would stop and switch back. And I think this is better to just be able to. All right, so we're going to go west. You're in the midway. An aid station is to the north. The sound of gunfire comes from a shooting gallery to the south. We can go to the shooting gallery. We don't have any money to play it. There's a picture of the shooting gallery. Isn't that adorable? And then go back to the midway. And this room has a restaurant to the north. That sounds like fun. Let's go to the restaurant. You are in the restaurant. The room is crowded, but you see an empty table in the corner. This location contains nothing. Visible exit south. A waiter approaches and asks if you would like a seat. Since you missed lunch today, you are hungry. Do you want to eat? Oh, yeah. You are served a delicious meal. Unfortunately, the service is rather slow.
What the?
The bomb went off. Oops. The bomb went off and the bomber escaped. It is 1 year later. The roller coaster has been rebuilt. The saboteur has decided to try to plans to destroy it again. Would you like to try to save it?
No. Play that video again? No.
So it combines still frames, it combines movie sequences, and it is, without a doubt, the first video game that included laser video. And are there any questions?
Have you successfully saved the roller coaster?
I have saved the roller coaster. Carrington has saved the roller coaster. It took him 45 minutes to do it. It's not a very long game.
But like 10 years.
Oh, and 10 years. When it says it's been a year later, the roller coaster's been rebuilt. It took him 45 minutes and 10 years.
10 roller coasters.
10 roller coasters. We decided that maybe he was behind. He was actually bombing the roller coaster, or he was the roller coaster company that sells roller coasters or something. He was benefiting from this one way or the other. This will be on display in just a few minutes during the vendor fair. I'm going to set it up somewhere and with little smaller monitors, and you can try it out if you want. The code for everything is on GitHub, and I had a lot of fun doing this project, and thank you for watching.
Fun except for the serial part.
So much later. Which one laser disc is it? I'm sorry, which one laser disc player? Or DVD player?
Oh, yeah, I didn't say that. I will tell you in a moment.
Thank you, Kevin.
There's only one. I think it's DVD 20 Pioneer DVD 2200, but literally there's only one. You'll find it. It's readily available on eBay, and it's not expensive.
From the actors.
Thank you, Kevin. So, in about 20 minutes, the vendor fair / exhibition / swap meet is going to start. And usually we rearrange this room radically for that. I'm thinking the bad part of that is then we do the awards and everybody needs a place to sit again. and we need to project again. So let's not do quite so radical a rearrangement until somebody tells me otherwise. I think maybe if we just take most of the things off the tables, like the lamps, and shove the chairs up against the tables, I think it's probably good enough.
To put back.